You know those big electronic signs with lights, color, animation? Well, this little thing is where it all starts. Digital electronic signboards are sometimes used as giant television screens or to post written messages. They come in different sizes, from a few meters all the way up to several hundreds of square meters. The creation of a sign starts with plans drawn by engineers and architects. Hundreds of plans are created by computer, among other methods, and require between 2 days or even a month of work. Millions of tiny lights, or light-emitting diodes called elements, make up the screen's surface. These elements are made of germanium, gallium nitrate, and silicon semiconductors covered with plastic. These elements have to be placed so as to form a matrix. Each of the 20 machines at this plant can install and solder 1,500 elements an hour. Lighting up an element requires only 10 to 20 milliamperes, and they last for about 150,000 hours. All the wires are placed behind the matrix and the different electrical connections. This conceals everything behind the sign and shelters it from the weather. Depending upon the distance from which the sign will be seen, spaces between the elements vary from 2.5 millimeters to several centimeters. A workman now makes the electrical connections. The wires have to be solidly connected to resist shaking caused by movement of the signboard. The matrices must operate together and require controllers which send information from one to the other. Thus, each group controls its own image. Each matrix has to be electrically powered and integrated to its own 5-volt element illuminating connector. Sometimes the matrices are made in 2 pieces, one supporting the elements and the other having the components. In this case, it simply requires 2 cards to establish the contact. Now they connect the information cable, which lights up and extinguishes the elements. Each matrix has 2 connectors, one which supplies the electric current and the other which carries the sign's information. Here they verify the functioning of each matrix. Then they can begin to join matrices together to construct the signboard. We see here all the colors assembled as they will be on the screen. The boards are sometimes installed outside and are thus vulnerable to the weather. That's why they put on this rubber strip which waterproofs it. The matrices are now assembled together. Then 10 matrices are joined to make up a module. At this stage, they insert the signboard conductor. Then the wires are connected. These wires transmit electric current and all the information relating to the sign. The elements require a very low voltage current, about 5 volts. Each module is then provided with its own converter to maintain a steady voltage. Then all the modules are assembled in the signboard support, and the many electrical connections linking the different modules are made. This gigantic signboard is a composition of 35 modules and 12 matrices. The signboard is almost finished. They now check the color, the luminosity, and the resolution of the screen. The signboard is made of 120,000 electrical light diodes and took nearly 3 months of work. Each year, this company constructs hundreds of digital signboards requiring about 100 million lighting elements. I've never been an early riser, but hey, I've got to eat. So I have a bowl for breakfast, a snack bar on the run. Thankfully, the goodness of cereal comes in many forms. Our breakfast cereals were born out of religious beliefs of the American Seventh-day Adventists, vegetarians, who in 1860 founded a sanatorium where patients were fed only cereals, wheat flakes invented by Dr. John Harvey Kellogg. His brother, William Keith, saw a promising future and built the first flakes factory to market the product, whose success would later be imitated by the famous Charles William Post as Post cereals. The making of frosted corn flakes starts in this cooker. The corn kernels are cooked here for 2 hours and 20 minutes. The corn kernels are then ground up. They're ground up by this endless worm screw. It also determines the number of kilos of kernels needed to make up a cereal recipe. The ground corn is next dried in a dryer unit, an important step before they're cooked. To give them their nice flat shape, the corn kernels are crushed in the flake roller. 2 rollers turn opposite to each other, and the kernels fall into the constricted space between them. The flakes then fall onto this conveyor, and the next step will be cooking. The flakes arrive at the cooking oven. They're shaken to make sure they will be uniformly browned. The flakes exit the oven well browned. Then they fall into this chute and head in the direction of the next step. This vibrating conveyor sorts the flakes and retains only the right-sized ones. This drum mixes the flakes and sprays them with a sweet solution boiling at 230 degrees centigrade. The sweet solution is dried, and a rake uniformly spreads out the frosted flakes on the canvas. Now they add in vitamins. The cereals are placed into this rotating drum. The vitamins are sprayed onto the flakes by a series of jets. The cereals are now finished, and they head toward the packaging site. This packager fills the bags with cereal. It handles between 40 and 45 bags a minute before they head off for final packaging. This plant doesn't only make cereals, it also makes soft cereal bars. This kneader mixes the ingredients, oat flakes, rice, and syrup. The preparation is mixed twice a minute. When well mixed, the preparation is poured into a large container. They will now proceed with the molding of the bars. The contents of the bin are emptied onto a conveyor, and then the preparation is spread out. Here they add chocolate chips to the preparation. The mix is compressed to the desired bar thickness by this roller. The bar separator then divides the mix into 35 equal strips. And then a guillotine cuts the bars to their proper length. The bars continue circulating. This equipment is used to line up the bars and make the packaging process easier. Side by side, the bars are here turned so that they run one behind the other. This roller applies a delicious caramel fondant to the bars. This caramel fondant then cools and sets. They're now at the final stage of production, coating with chocolate. About 180 kilos of chocolate are needed for the bar recipe. Now finished, the bars are ready for packaging. This machine individually bags the bars. Finally, they proceed with the packaging. These tasty bars will be enjoyed by children as well as adults.